Hello friends, it's Miss Stephanie from Squixy.
Yay!
Have you ever lost something and then found it?
Bingo!
Have you ever completed a really challenging puzzle?
Alright!
Have you ever found Halloween candy you forgot about in March?
Come on!
Let's recall the different math words in a multiplication sentence or equation. A multiplication equation has two parts, factors and the product. The commutative property of multiplication tells us that the factors can be in any order and the product will be the same. For example, 6 times 9 is the same as 9 times 6. Both products are 54. As I was saying, the commutative property is the...
Hey, I got your orders here. I got two 54s. I got a 6 times 9. That you? And I got a 9 times 6. Those yours?
Yes, that's it. That's the commutative property. Next, I'd like to tell you the different parts of a division equation. There are three parts in a division equation. The dividend, which is the largest number that is being divided. The divisor tells you what number to divide by. And the quotient, which is just a fancy name for the answer.
Alright!
54 is the dividend in this example. 9 is the divisor, and 6 is the quotient. 54 divided by 9 equals 6. And that's the same as 54 divided by 6. That's 9. As you learn more about operations and algebraic thinking, you will come across problems that have one of these parts missing. The best thing to do when this happens is to think about the fact family. Remember that a fact family is a set of math facts related by inverse or opposite operations. For example, 4 times 5 is 20, 5 times 4 is 20, 20 divided by 5 is 4, and 20 divided by 4 is 5. This is based on the commutative property of multiplication. Now we're ready to solve a word problem. Let's try a word problem to help us understand how to find the unknown. Consider this problem. 6 Pofflians go to the Pofsa Palace.
Bingo!
They each spend $3. How much do they spend all together? Drawing a bar model can help us visualize this equation. The information in the problem tells us that there are 6 Pofflians. And if you're following along in the book, you know all about Pofflians and their obsession with pizza. 6 Pofflians each spend $3. We don't know the total amount that they spent, so that will be represented with a question mark. 6 groups of 3 can be represented using multiplication like this. I can also use repeated addition to explain my thinking. 3 plus 3 plus 3 plus 3 plus 3 plus 3. 6 groups of 3 is 18. 6 Pofflians spent $18. Well done, friends.
Yay.
Let's try another word problem. Trixy has 28 eye patches to match outfits in his wardrobe. If he wears the same number of eye patches every day of the week, how many does Trixy wear each day? In this problem, I know how many eye patches Trixy has. So when I make the bar model, I know the whole number will be represented by 28. I also know that there are 7 days in a week. So I'm going to divide the bottom part by 7 equal groups. 1, 2, 3, 4, 5, 6, whoops, 7. Each day, we don't know how many eye patches he wears. So I'm going to put a P for patch. In this equation, I know that Trixy has 28 eye patches. I also know that there are 7 days in a week, so the equation is going to look like this. 28 divided by 7 equals P. How can I figure this out? I know that if I use the inverse operation, I can turn this into a multiplication problem. 7 times what, patches, equals 28. How many groups of 7 make 28? Let's try this. Here are my 7 groups. I need to figure out how many eye patches will go in each group. I will place 28 objects in 7 groups to find out. Remember that each group represents a day of the week. Here we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. How many patches does Trixie wear each day? How many objects are in each group? 4. P equals 4. Nice job, friends.
Yay!
Let's try finding the unknown one more time. In this problem, Gubbleberry jam costs $9 per jar. After the first day at the Waffle Jubilee, $72 was collected at one booth. How many jars of jam were sold? In this problem, we know how much money was collected. We also know how much each jar cost, but we don't know how many jars were purchased. I'm going to draw a bar model to show my thinking. The 72 represents the total amount of money collected. $9 indicates the number per jar, but we don't know how many jars were sold. The expression will look like this. $72 divided by 9 equals big fat question mark. How can we figure this out? Let's use inverse operations. 72 divided by 9 is a mystery, but I can reverse the problem and turn it into a multiplication problem. 9 times what is 72? How many groups of 9 do I need? Before we solve this, let's try using a number line. On my number line, I am going to skip count by 9. It's really important to know your multiples, but if you need some think time, that's okay. Nine, 18, 27, 36, 45, 54, 63. The next number is 72. How many times did we skip count by 9? 1, 2, 3, 4, 5, 6, 7, 8. That tells us that there were 8 gubble jars sold at the Jubilee. Let's relate it back to the bar model. The original bar model looked just like this. The whole number was 72 because that was the total amount of money collected at the Jubilee. Each jar of jam cost $9. We didn't know how many jars were purchased, so this part was a big fat question mark. But after using the inverse operation, we found out that there were 8 jars sold. That means that the bottom part of the table is going to be split into 8 equal parts. 1, 2, 3, 4, 5, 6, 7, and 8. Each jar was $9. 8 jars were sold. Remember, friends, there is more than one way to solve a word problem. You might use the inverse operation, you might create a bar model, skip count, use a number line. The possibilities are endless.
Yay!
Keep up the good work, friends, and remember, learn fast, learn fun.